Hello everyone. So welcome to my lecture video for exam P1. So I'm Dr. Wang. So in this video we will discuss problem from 101 to 110. Okay. So problem 101 it says we want to find we want to find the variance of z. So we want to find vz, right? So what is z? So z equals 3x minus y minus 5. So at first we say constant variance for constant is 0, right? So we can remove this constant. Okay. So this variance equal, we say this equal v 3x. We can use the formula. So actually like vax plus by. We have this formula equal. Maybe we just use this formula equal a square vx plus b square vy and plus 2ab covariance of xy. So here we just use the formula to calculate. So this equal 3 squared 9 vx plus b squared negative 1 square, so plus vy minus plus 2ab, so minus 6 covariance for xy. So here x and y are independent, so covariance equals 0, right? So this is just equal 9vx plus vy. So then we just go back, we find what is vx? Vx equal 1. What is vy? Vy equal 2. So this is just equal 9 plus 2. Okay. So problem 101, it says what is the variance of total time? So what is the total time? So the time is like we have two electric generator. We have two. So if first one fail, we just use the second one. So the total time is t is first the time for first generator. So we denote this as x, and then when this fail, then plus the time for second generator, right? So we want to find vt, variance of t. So we say is this equal vx plus vy plus the 2 covariance for xy, right? But this x and the y are independent, so covariance equals 0. So just equal vx plus vy. So this x and the y is same, so just equal 2vx. So what is vx? So what is x? So we say x follow exponential distribution. So mean is mean is 1 over lambda. Mean is equal 10. So we know its variance is 1 over lambda square, right? Variance equals that. So 1 over lambda is 10, 1 over lambda square is 100. So that's equal to 100. So for problem 103, we want to determine the probability that the maximum of this loss, maximum of this losses. So we have so we have 3 losses like this. So we put this as x1, x2, x3. Okay. So what we want to find? So let's say let this y equal maximum of x1, x2, x3. So what we want to find is this y is larger than 3, right? Exceeds 3. So when we're talking about the maximum, so we need to change this to less than. Okay. So when maximum is less than 3, so this means each one less than 3, right? So this equal 1 minus, so p, let's say x1 less than 3 and x2 less than 3, x3 less than 3. Okay, like each one maximum less than this number means each one less than. So what is says those probability? X1 less than 3. So what is x1? So x1 follow this x1 follow an exponential distribution. Okay, and this lambda is 1 over 1 means 1.0, right? So 1 over 1.0. So we know this probability is 1 minus negative lambda times 3. So 3 times this. Okay, so just 1 over 1.1 is 1. So thus. And this one is negative 3 times lambda, the lambda 1. So 3 over 1.5, right? So lambda is 1 over 1.5, and then here is negative 1 over 2.4 times 3, so 3 over 2.4. So use calculator, we can find this. So for 104, we want to find what is the covariance of this. So covariance uses the formula xy equals this, like equal exy minus x times y. So here we just need to find x, y, and x times y, right? So what is x? Let's see. What is x? So x just equal. So this is okay. So this density function. So okay. So range is x from 0 to 1, y from 0 to 1. So x from 0 to 1 dx, and y from 0 to 1 dy. So here x, then x, then fxy, so kx dy. Right? So this is x, and y, we just change this x to y, right? And let's see, so what is y? So y equals us. Like, say x start from 0 to 1, and y from 0 to also 0 to 1. Then here just y kx dx, kx dy. And what is xy? So xy is just equals this, right? 0x from 0 to 1. Then once we determine x, so y, we say y equal y start from 0 to 1. So here x times y kx dy. All right. So what is k? What is k? So we know there's a probability, total probability equal 1. So we let this 1 equal. So there's all probability is kx dy. This equal 1, right? So there, let's find this integration. So here kx dy, just kx. So kx, so the dx. So this equal k times x dx integrated half. So we know k equal 2. Okay. So we just plugging in k equal 2. So we can find we can find x, y, x, y easily, right? Then we can find covariance. Okay. So for this problem, also find covariance of x, y. So use the same thing, like, okay, so we need to find covariance. At the first, use the formula covariance equal xy minus x times y. So here we just need those integration, find those 3 integrations. So let's say what is xy? So equal. So we determine x from 0 to 1 dx. Then once we determine x, then what is y? So y between x to 2x, right? Dy. Okay. Okay. So integration functions x, y, and f x, y is a over 3 x times y. So x, y is just this integration. So this integration, I think, is easier. So let's say x from 0 to 1. So here, so integrate this part. So we just take this constant outside. So here, x, a over 3, all are constant, right? So here we say this x squared, x times x, and a over 3 dx, right? Then for this part dy, so dy is y squared dy, right? Y squared dy, so y squared is 1 over 3, so y 3. So this is 3, so minus x 3. So, right? So then dx. Okay, so this finally we just say this integration is we take okay. So this is, let's say 2x3 minus x3 is 7x3. So we take this, so it's constant outside. Okay, so then this is x2, x3. Right? So this x5. So x5 integration is 1 over 6. So finally, so the answer is 8 times 7. Okay, so here 9 times 6. Okay, so this is just x, y. Then we need to find x and y. So such a problem, just the integration problem. Okay. So problem 1 over 6, also we need to find this. Okay. Okay. So here we say we need to find just use the same formula. We need to find this and x, y, right? Okay, so now let's check x. So x equals, so we need to determine x from where to where. Okay, so it says like x is uniformly distributed on this 0 to 12. So this is x 0 to 12. So then for y, so this is giving x equal x. So giving this x equal x, this line, x equal x. So y is uniformly on the interval from 0 to x, 0 to x. Okay. So this means like y is uniformly from 0 to x. Okay, so we can know so x from 0 to 12, right? Okay, so we know the x, y, the region is this. There's a triangle. And the density function f x, y, the density function is constant. Right? Is equal k. So at the first we need to find this k. So what is k? So all probability equal 1. So we say this k. So we just find the integration of this area for this triangle. So area is 12 times 12, right? 12 times half. So half. So here half of 12 square. Just 1 over the area for the triangle. So this is the k. Okay, so now what is x? What is x? So by now it's easy, right? So x equals 0 to 1. Oh, 0 to 12, I'm sorry. X, then dx. Okay, so what is y? Y is from 0 to x dy. So integration function is x. Then f x is just k. Right, constant. So this equal, we can take a k outside. Okay, so here x and here from 0 to x dy is also x, so this equal x squared dx. So this equal k times 1 over 3, 12, 3, right? So what is k? So we say k equals this. So we can put a 2 over 12 square. This is k, right? Saying 1 over 3, 12, 3. So then we can cancel 12. Okay, 12. And then here cancel this. So x, we find this equal 8. Then find y. Then find x, y. Okay. So we say there's such a problem is just the integration. Okay. Okay. So for this problem, we want to calculate the covariance for C1, C2. So what is C1? So this is C1 equal x plus y, right? C1 is x plus y. So before the application of 20% surcharge. So what is C2? C2 is after. C2 is, it says after the application for the application of that surcharges. So this means C2 equal 20%, 1.2 of x plus y. Okay. Okay. So covariance of C1, C2 equal covariance of x plus y and 1.2x plus 1.2y. So this equal so just a multiplication like this. This is just x plus y multiply 1.2x plus 1.2y. So at the first we have 1.2 covariance for x and x. So this is just Vx. And plus like xy, 1.2 xy or 1.2 yx. So yx, xy is covariance the same. So that's equal 2 times 1.2 covariance of xy, then plus 1.2 vy. Right? So what is Vx? We already know Vx. So for Vx equal x squared minus x minus x squared. So we already know Vx equal 27.4. So x equal 5, so 5 squared. So we can find the Vx, right? So 27 minus 25, 2, so 2.4. So same way we can find Vy. Right? We know Ey squared and we know Ey. Then we just need to find what is the covariance for x, y. So covariance xy we need from here we find. So let's say covariance x plus y equal a. So this variance okay. This variance equal Vx plus Vy plus 2 covariance of xy, right? So we let this equal 8. So we know Vx, we know Vy, then we can find covariance for x and y, right? Okay, so then finally we can find plug in, so we can find covariance for C1, C2. Okay, so for this problem, we want to find the density function for this x. So what is x? So x is thus. We can say x equal 2t1 plus t2. So we want to find the density function for this x. So to find the density function for x, our method is find the cumulative function of x. So let's find this. Let's say fx. We want to find this fx. So fx equals this. This x less than x. Find this fx cumulative function. Then use derivative. We can get a density function, right? So this x less than x, this probability is equal. So equals this, right? So 2t1 plus t2 less than x. So we need to find this probability. Okay. So then we need to find so what is t1 t2? So we find t1 t2 is t1 t2. So the t1 t2 have the density function is e negative t. So this actually is exponential distribution, and the t1 t2. So there is just from 0 to infinity t1 t2. Okay. So what is where the so what the probability to t1 plus t2 equal less than x? So let's say the equal x. So equal x. Let's equal x this line. Okay. So this line is 2t1 plus t2 equal x. So here we just fix this x. So this probability is we need to find what is the probability for this part, right? So this equal x less than x is thus. There's a triangle. So here's 0. Yeah. Okay. So let's say we need to find this integration. So let's say check t1. So t1 from 0. Okay. From 0 to this. Okay, so this is we let t2, there's a point t2 equals 0. So t1 is x over 2, right? So t1 equal x, t1 equal x over 2. So dt1, okay? Then once we determine this t1, so what is t2? T2 is from 0, this line, from 0 to this point, from here to here. So this t2 equal x minus 2t1. Okay, right? Then dt2. Okay, so then here density function for t1, t2. So density function for t1, t2 is e negative t1 times e negative t2. Right? Okay, so we just find this integration, find this. So let's say that this equal 0 x over 2. So dt1. Then okay, so here the integration dt. So about the dt2. So e negative t1, we can take it out. So this integrate this e negative t2. So this equal 1 minus e negative x minus 2t1. So dt1. Okay. So this equal 0 to x over 2. So e negative t1, so minus e negative x, and times, so here positive 2t1 minus this become e t1, positive t1, right? Okay, dt1. Okay, so for first part we can integrate out e t1 negative t1 dt. So this equal 1 minus so negative x over 2. So minus x, we take the x other side. So this t1 dt is x over 2. Sorry, negative x, I'm sorry. So this et dt is equal et, so x over 2 minus 0, 1. So here simplify a little bit, is x over 2. And here is also x over 2, negative, right? X over 2. And here plus negative x. And finally this equals, so here this equal 1 minus, 1 minus this minus 2 is negative x over 2 plus is negative x. Okay, so then density function is just a derivative, right? So there's a derivative. This one equal negative x over 2, right? So it's derivative minus negative x. Okay. So for problem 109, how does the same? We want to find the density function for x. Density function for this x. So what is x? This is x is ratio of cream to premium. So cream to premium. This is x. So what is cream? So we denote cream. Let's see. Okay. Cream, let's say cream is an exponential random variable with mean 1. So this is cream. So maybe we denote this as, suppose this y. Cream is y over z. Okay. So y meaning cream, so y follows this. And lambda equal 1, right? So what is z? So z is premium. Premium is also exponential distribution. So z follow exponential distribution, and mean is 2. So mu is 2, or mu is half. Okay. So we want to find the density function for this y over z or x. So the idea is quite the same. So we need to find cumulative function fx. So fx equal x less than x. Okay, so less than x equal y over z less than x. So y over z less than x equal py less than x times z. Okay. So what is, so we want to find is the probability. So for x and y, we know x, y. No, I'm sorry, y, z. So here's y, here's z. Okay. Y, z from 0 to infinity. So, okay, so this line related equal y equal xz. So y equal xz, so this line. Suppose this is y equal xz. So where is y less than xz, or y larger than xz? So here we need to be careful for like with this line split this first quadrant into two parts. So we need to determine which part. Okay, so we can say like here y equals, here is, let's say y equals 0, y equals 0, this line here y is 0. Okay, so we know this part y is small. Okay, so we know this y less than xz should be this part, right? Okay, so once we know this, okay, so then we can find this probability, or we can do those calculations. So let's say we first determine the y. So determine y. So y start from 0 to infinity. So once we have this y, so determine this z. So z is like from this point to infinity. So this point z is y over x. So here x fixed, right, to infinity. So this is z. Okay. So the density function for yz is negative y negative half z. Okay. So by now we just need find this integration, and we said okay. So here x is fixed. Yeah. So let's say this equal. We but take negative y to here, 0 to infinity. So negative y. Okay. So then this integration. Oh, I'm sorry. This exponential density function is lambda is negative lambda. Yeah. So here f density function for exponential lambda is negative lambda x. Okay. So here, if lambda is negative mu, so here is mu equal half, then here we have coefficient. I'm sorry, I made a mistake. Coefficient half. So put half here. Yeah, we have this coefficient. So then this is we put it to here. Okay. Then we need to find this integration, right? Now half. Oh, maybe we don't need to put this half outside. Just we for exponential distribution we use this lambda is negative lambda x dx if from a to infinity. So this just equal lambda. This is just equal negative lambda a. Okay. Yeah. Okay. So we just take negative y outside. So this integration is equal lambda like negative lambda a times y over x. So then dy. Okay. So this equal. So here remember x. We need more space. But here, okay. So this equal 0 to infinity. So x constant. Okay, remember that. So this negative y coefficient is 1 plus 1 over 2x. 1 over 2x y dy. Okay, so this integration, we also use this formula is called, maybe this is should remember this, like 0 to infinity e negative lambda x dx equal 1 over lambda. So this equal 1 over 1 plus 1 over 2x. Okay, so this is fx. Then density function just the derivative, right? So by the way, this function we can simplify a little bit. So multiply 2x, so that's equal to 2x. So 2x plus 1. Okay. Okay, so for problem 1 and 10, we want to find this probability. Okay, so find the probability. So here's a find a p actually. I'm sorry, we want to find a p probability for y less than x when x equal 1 over 3. So there's a conditional probability. Okay, so let's say this x and y is this, x from 0 to 1, but y is from 0 from 0 to 1 minus x, or we let it y equal 1 minus x. We know this is just the x plus y equal 1, this line. Okay, so this is x plus y equal 1. Okay, so here's 0, here's 1. Okay, so the question is when x equal 1 over 3, when x equal 1 over 3, so how much part is y less than x? So let's check y equal x. So y equal x, so this is y equal x. Okay, so we can say, okay, so this is y. Okay, so y, so where is y less than x? So here is totally is this part, right? From here to here, x equal 1 over 3, and y less than x is this part. This part. So this part count for how much for total? Okay, so we say, so we just focus on this line, now x equal 1 over 3. So density function, so we can say density function about y. So x is constant. So density function, so y can change, right, from here to here. So y can change. So density function for y is just 24 or x 1 over 3 y or ay. But actually ay maybe is cannot guarantee. So here we just replace x by 1 over 3. But when we just replace x by 1 over 3, we cannot guarantee all probability is 1, right? So for conditional probability, we need to adjust it. So we can say this is just some coefficient k multiply y. Okay, so this k is just make sure this for this conditional probability, total probability will become 1. Okay, so what is the k value? So here we temporarily don't care about that. So we can say, so there's a probability we want to find is first one, total probability. Total probability is so y from 0 to thus. So this is y when x 1 over 3 is 2 over 3, right? So ky dy. So this is total. Okay. So what is y less than x? So y less than x is this part. So x, the y from 0 to 1 over 3, right? So this point 1 over 3. So ky dy. So this is our probability, conditional probability. So from here we can say, oh, this k we don't care, we can cancel. So this equal, we forget this k. So this integration is half of y3, so 1 over 3, half of this square, yeah. Y dy is half y square. So here also half this square. Okay, so cancel. So we find this just 1 over 4. Okay, so this is the problem from 100 to 110. So we can stop here and see you next video. And thank you for watching.